Hey there, welcome back to Wingman. Today we are diving into two essential concepts that are going to be very useful for us. These are CVSM and RVSM. Don't worry if you've not heard these terms before, I am sure that you've had a little or a certain idea about them. So let's break it down in the most simple way. And why is this essential towards RT? We'll understand as we go. So in this video, we'll be discussing about what CVSM is, what RVSM is, and how are we supposed to give our RTR calls in the exam in various situations. So we'll look about it in a step-and-step manner. So let's begin with what CVSM is. CVSM by definition and by full form stands for Conventional Vertical Separation Minima. What this means is this was an older system of vertically separating aircrafts. If I were to explain it to you in one line, CVSM says that this minimum separation between aircrafts vertically has to be 2000 feet. Meaning, let's say one aircraft is at 30,000 feet, the other aircraft, whatever the aircraft is, it can only next be at 32,000 feet, or it could have been at 28,000 feet. Okay, that's what CVSM says. But let's see how was the system made. So we're going to do an exercise and we will keep progressing forward and we'll try to build this model that CVSM is. So the lowest flight level is flight level 50, right? So keeping that in mind, we divide a compass, okay, into two halves. Let's say we divide it into two hemispheres rather. The first hemisphere starts from the reading of 0 degrees and goes all the way till a reading of 179 degrees. The second hemisphere begins with 180 degrees and ends with a reading of 359 degrees. Now, any heading from 0 degrees all the way to 179 degrees, okay, is counted towards the eastern hemisphere. Okay, and anything with a heading of 180 to 359 will be counted in the western hemisphere. Okay, now that we have our basic details in place, let's begin. So the lowest flight level that is possible is flight level 50. Fine. Now one of the most crucial rules, and the reason I was telling you that you've probably heard about CVSM and RVSM is because in our previous videos we've already spoken about how westbound and eastbound routes are decided. For those of you who are not familiar with it, what we've done is, if now you've understood how have we formed this eastern hemisphere, what I've done is I have said that anybody flying in the eastern hemisphere, that is a eastbound route, they will have to fly all the odd levels. Okay, and all the westbound routes will fly even flight levels. Okay, so you're only looking at the first two digits because all of them are going to probably end with 0 or with some other number. So you're just going to look at the first two digits to decide which one of them are even and which one of them are odd. Like in our case, flight level 50, 5 being an odd one, we have it in our eastbound routes. So any aircraft that has to fly eastbound, that is any aircraft flying with a heading of 179 or any heading from 179 to 0 will have to fly on an odd flight level, irrespective of which direction is it going. Okay, it will have to fly a odd flight level. So our first flight level is flight level 50. The next flight level is what? Think about it. It will be flight level 60. Then we have flight level 70, flight level 80, and so on and so forth. It keeps going on until we finally reach flight level 150. Okay, now here's where the first restriction comes about. What does the first restriction say? The first restriction says that, hey, VFR flights are not above this flight level. So in this direction, it's only IFR, and in this direction, it's IFR plus VFR. Okay, so any flight level from 50 to 150 can accommodate both IFR and VFR flights. Anybody above flight level 150 is going to have only IFR flights. So that's our first restriction. Second, again, we keep continuing with this odd and even flight levels. So I say my next flight level is flight level 160, then it comes to flight level 170. Okay, and so on and so forth. It continues all the way up till flight level 290. Now, when you draw it, or if you have time to draw it on yourselves, you realize that 29 is a eastbound route, right? Now this is where the two systems change. Okay, everything until up till flight level 290 is the same between CVSM and RVSM. Everything functions the same way. But it's above this that they're different. That is above flight level 290. So now since we're talking about CVSM, the next flight level, I say, according to CVSM's rule, I say that CVSM, the minimum separation has to be 2000 feet. Fine. Now, if I look at my diagram, where do you think I'm going to have the minimum separation between two aircrafts? I could have one aircraft which is going in this direction and one aircraft which is going in this direction, right? One is flying on an eastbound route, other one is flying on a westbound route, okay? And this is the minimum separation, which is 1000 feet. Okay, this was all below flight level 290. Okay, so this separation is called as reciprocal track separation. Okay, so what's the reciprocal track separation in CVSM below 290? The reciprocal track separation is 1000 feet, and the same track separation, both eastbound tracks, they're separated by 2000 feet. This is all below flight level 290. Okay, the moment I go above flight level 290, I tell you that the same track separation becomes 4000 and the reciprocal or minimum separation becomes 2000. So everything is double now. Fine. So first let's ascertain something. If I say that above flight level 290, I want to follow CVSM, okay, then the next flight level which is available that my airplane can fly on has to be at least at a minimum difference of 2000. So the next available flight level will be flight level 310. Fine. But now here's a question. Flight level 310, if I were to follow the odd and even rule, flight level 310, 31 being odd, it would have again become an eastbound route, right? But that's not the case. Why is that not the case? Because 290 was itself an eastbound route, and the next route again cannot be an eastbound one. So, lack of a better choice, I had to put it here, okay? Then again, flight level 320, it'll be flight level 330. Fine. Then it'll be flight level 350. So there are 2 points to note here. One, am I following all the rules? Minimum separation, is it not 2000 feet? Yes, it is 2000 feet. Same track separation in CVSM, isn't it 4000 feet? It is 4000 feet. So everything has doubled now. Okay. So on and so forth, we keep continuing, and this system goes up all the way up until, okay, CVSM starts from 290 all the way up to 410. Okay, fine. Now the question is, why was this done? Okay, the question is that why was this done? I have said that above this, everything is CVSM. Okay, minded that this was an old system. The reason this was done is, back in the day, the instrument used to measure altitude. They were not that precise. Okay, we used to have pressure altimeters. Okay, even servo altimeters had not come up by then. Right, so the instruments by themselves were not very efficient and precise. So, in order to reduce the risk of a collision, we increased the distance between these two aircrafts. Think of it like a buffer. Okay, they needed that extra buffer in order to maintain safety because their altimeters were giving a different reading. They were giving a little erroneous reading. And that's the whole reason CVSM came into play. I'll go about it again. The reason CVSM came into play, okay, was because above flight level 290 at those high altitudes, our altimeters were not giving us precise indications. So in order to keep them safe, I had to increase the distance between them. I doubled the distance between them. Okay. In order to give them that one extra buffer. So fine. So I realized that in CVSM, my core problem was my altimeters not reading correctly. Fine, technology progressed, everything went forward, aviation in general moved forward. And then we came up with something that's known as, RVSM. Why did we get RVSM? Because our ability to measure that altitude had improved now. Okay, we could measure smaller deviations, we could measure it more precisely, more accurately. Fine. What happens in RVSM? So the same thing, like I told you, everything is same up until flight level 290. Okay, everything is same up until here. What changes? What changes is that the separations remain the same, like they were below flight level 290. Meaning now my flight level was 290 here. My next flight level will again be separated. Okay, my minimum separation now in RVSM, my minimum separation has dropped down to 1000 feet, like it was below flight level 290. Okay, again below 290, CVSM, RVSM both are same. The systems are only different above flight level 290. So fine, I told them that your instruments can read correctly. You do not need that buffer now. You can fly a little bit closer to each other. You can fly safely. So the next available flight level at a separation of 1000 feet from flight level 290 would be flight level 300. And 290 being a eastbound route, my next flight level would have to be given to a westbound route. But again, this again puts everything back on track. The odd even rule is still being followed. Plus, the major advantage I had was that my aircrafts I was able to get more flight levels. Okay, in the same amount of space. Initially, I could go only from 290 to 410. Okay, with a reciprocal track separation of 2000 feet. That left me with roughly only 6 to 8 flight levels. But here, theoretically, the levels have doubled, right? Because I've reduced the space by half. So if I continue building the model, I'll reach flight level 300, then flight level 310, then it will be flight level 320, 330, and so on up until 410. Fine. So this is the crucial difference when you diagrammatically draw, CVSM and RVSM. This is the difference between both of them. So now let's look at some requirements. Okay, you need to realize something, that our requirements, to fly in RVSM are very, very strict. Okay, again, air traffic controllers can manage the airspace more effectively in an RVSM. Okay, now one other advantage of RVSM was that all aircrafts could now fly at their best or the most economic flight level for them, depending upon their model, their fuel efficiency, their engines, whatever. So it worked in everyone's favor. Okay, now RVSM didn't just happen overnight. Aircrafts and their operators had to maintain and still have to maintain very, very strict requirements to fly in RVSM airspace. This majorly revolves around the core problem of altimetry. Okay, these all requirements revolve around your altimeter readings, about your heights, because that was the only problem, right, between CVSM and RVSM, that we were not able to measure height correctly. Now we are able to measure height correctly. So what all do we need? Okay, there are 5 basic requirements which you will have to keep in mind when you're talking about, when you're thinking about it in terms of RTR. So your first requirement would be that you have to have a 2 separate altimeter systems. Why is that? Okay, see, your one altimeter could fail, just as a backup, you need to have another one. Okay, so you need to have two separate altimetry systems. You should have a autopilot. Okay, you should have an autopilot which is capable of maintaining whatever flight level you've chosen within plus minus 50 feet. Okay, whatever you've directed the autopilot to hold, it should be capable and advanced enough to hold that altitude within a buffer of 50 plus minus 50 feet. Third, you should have a altitude warning device. Okay, meaning anytime that you've chosen an altitude, okay, anytime you deviate, be it the pilot or be it the autopilot, if you deviate by more than 300 feet of the selected altitude, it should sound an alarm. Okay, it should be able to alert you. Fine. Fourth, you should have a mode C or S transponder. Okay, you need to have a mode C or S transponder. Now, pilot in command aircraft have to be RVSM approved. All right, fine. So we have these 4-5 basic requirements. You have two separate altimetry systems. Your autopilot, you should have an autopilot and capable of maintaining plus minus 50 feet. You should have an altitude warning device which can indicate if you deviate by more than 300 feet. You should have a mode C or S transponder on board. Your PIC, your aircraft and your equipment have to be RVSM approved. Apart from this, which talks about altimeter, one of the most crucial rules about RVSM is that you cannot fly in turbulence. So you cannot fly RVSM in turbulence. Okay, so these are few very basic requirements. I need you to have this by hearted because they will fail only one of them or two of them or whatever in your exam, but you should know that this was crucial towards your RVSM, to fly in RVSM. Fine. Now that we've spoken about what CVSM and RVSM is, I want you guys to just look at this picture just to solidify what we've studied so far. Okay, reciprocal track separation in CVSM. Okay, that's before RVSM, it was CVSM. So reciprocal track separation, if you see here, it is 2000 feet, it is increased, and same track separation is 4000 feet. Whereas in RVSM, the minimum or reciprocal track separation is what? It's 1000 feet, and same track separation is 2000 feet. Okay, they both go from 290 to 410. Okay, but their overall flight levels have increased. Here the available flight levels would have been only 1, 2, 3, 4, 5, 6 and 7. Here it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and 13. Okay, fine. Now that we've established what is important for flying in RVSM and what is RVSM, let's look at the RT calls, okay, that go about in RVSM. What kind of questions are you expecting? What kind of RT calls are we supposed to give? Okay, all of this is nothing. We've already spoken about this. We've already spoken about what CVSM is and what RVSM is, and what are the reciprocal traffic restrictions, what are the same track traffic restrictions, why does it happen. We've spoken about this all. Fine. Now, let's look at the formats. Okay, what kind of questions are we expecting when we talk about a CVSM, a RVSM call? Okay, one of the major things what we are expecting, okay, is that we will have our requirements. We could have anything. We could have a primary altimeter failure, if you remember. We spoke about this. We could have had our primary altimeter failure. Okay, we could have autopilot failure. We could have a mode C transponder failure, or we could be flying in turbulence. In any of these conditions, if mentioned, you will have to suspend RVSM. And major calls are going to be revolving around that itself, about you suspending RVSM. Okay. Now, how do you suspend RVSM? What is the logic behind it? See. Okay. Let's say you are flying in an RVSM airspace, and let's say you're flying at flight level 310, or let's say you're flying at flight level 350. Okay. So you're flying eastbound. Fine. Let's say that you now had a enable RVSM. Okay. Or let's say you had a RVSM failure. And this could be anything. It could be mode C failure, it could be primary altimeter failure, it could be anything of those 5-6 requirements you've spoken. Then what's my intention? My overall intention or plan is to get out of this RVSM airspace. And now, just retracing our steps. Where did RVSM airspace extend from? RVSM airspace extended from 290 all the way up till 410, right? So I want to leave this portion of flying. That's fine. So what I intend to do is I intend to descend down. Okay, I intend to descend down to the highest non-RVSM level. Okay, because I'm an eastbound flight, the highest non-RVSM level for me would be flight level 270, right? Because I have to be odd, because I'm an eastbound traffic, and below 290, this is the only highest eastbound non-RVSM level I can fly. So I'm requesting to fly 270. If I would have been flying westbound, I would have descended to flight level 280. Okay. But my basic intention is to get out of this RVSM airspace. Fine. So just like our previous calls, it's not going to be tough. It's going to have a basic skeleton, which I want us to follow. Fine. So the basic skeleton is going to revolve around, again, station called, basically which ATC or whom are you calling? The station calling, which is your call sign. What's your position currently? Okay, what's your position? What's the problem you're facing? In case of RVSM calls, our problem is unable RVSM due equipment, or we could be unable, to fly in RVSM due to turbulence. So there are only two broad problems we could face. It could be due to equipment, or it could be due to turbulence. Everything from your mode C failure, mode S failure, your primary altimeter failure, all of these things come under equipment failure. And turbulence is only when you're facing turbulence. So your problem is going to sound like unable RVSM due equipment or unable RVSM due turbulence. It's going to be one of these. And what is your plan? We just discussed. Our plan is to descend or climb, depending upon the situation, to the highest non-RVSM level. Right? And we're going to request permission for the same. That's our basic skeleton of the call. So let's try solving a question for this. Okay, I'll leave the format on the screen and I'll try to plot a paper. Okay, let's try solving a very quick question. Okay, let's say we are 1 Victor Tango Foxtrot Lima Alpha. We are going from 1 Delhi Papa November to Nagpur. Okay, so where am I going from? I am going from Delhi Papa. Okay, so I'm taking Whiskey 20 South all the way to Bravo Papa Lima. Okay, from there I'll be taking Whiskey 38 all the way to Nagpur. Okay, that's my route. Fine. I will be maintaining flight level 320 and 310. That's what's given in my flight plan. Now this one roughly looks, it's not a straight line. It's not flying on a heading of 180. It's going to be something lesser than 180. So this is a eastbound route, and hence you're going to fly on a odd flight level. So here you're going to fly on flight level 310, and on this leg again you're going to fly on flight level 310. Here again you're going to fly on flight level 310. Okay, fine. Now what will it sound like? Okay, the question says you're 20 nautical miles to Bhopal, that means we're roughly here, you're 20 nautical miles to Bhopal, and you experience a mode C failure, take action. Okay, that's what it says. You're around Bhopal, you're facing a mode C failure, take action. And we're 20 nautical miles to Bhopal. Now, this circle denotes a 25 nautical mile line or a boundary. So I'm roughly somewhere here, right? I'm within that boundary. Now, the station called. Whom am I going to call? Okay, keep in mind, I'm going to be flying flight level 310 here. Right now, my aircraft is flying at flight level 310. That should take you about a moment and you realize you will be calling Nagpur area control. So what will the call sound like? The call will sound like Nagpur area control. This is Victor Tango Foxtrot Lima Alpha. Right? Position 20 nautical miles, 20 DME to Bravo Papa Lima. At time 2210 hours. Flight level 310 on Whiskey 20 South. That's our position. What is our problem? The question says that we have had a mode C failure, right? So we are going to say we are unable RVSM due equipment. What is our plan? Our plan is to requesting descent to flight level. What would it be? Will it be 270? Will it be 280? Remember, we are in eastbound traffic here. So you have to always keep this in mind, okay? Especially in RVSM calls. So we're in eastbound traffic here. So the highest level we can afford or ask for, which is a non-RVSM level, is flight level 270. So what will the whole call sound like? Okay, let's write it here. Okay, the whole call will sound like Nagpur control. This is Victor Tango Foxtrot Lima Alpha. Right? Are you able to follow? Station called, station calling. What's my position? My position is 20 DME inbound Bravo Papa Lima. Right? That's Bhopal. At 2210 hours, flight level 310 on Whiskey 20 South. Right? That's my position. What is my problem? My problem is that I'm unable RVSM due equipment. Okay, what's my plan? My plan is to descend to flight level 270. Request permission. Right, it's very straightforward. Whom are you calling? Who is calling? What's your current position? What's your problem you're facing? What's the plan? Right? Very straightforward. Fine. Now, moving forward from this format is absolutely great, and this is the format you'll be following when you are in contact with the ATC. Okay, you are in touch with the ATC and you face a RVSM failure. But now what happens the moment ATC is not in contact, but you still have to, get out from an RVSM airspace because you'll pose a risk to the other aircrafts, right? So in that case, what do you do? Fine. So let's look at it here. Okay, let's just write here. No contact with ATC. And we are unable RVSM. Fine. Now, if you watch the previous videos, you'll realize, or you'll recall rather, that ATS routes we've discussed, they are 20 nautical miles wide over land and 40 nautical miles over sea. So it's 10 nautical miles this side and it's 10 nautical miles to the other, right? In total, it's 20 nautical miles wide, the center 10 and 10 spread both sides. And I'm an aircraft here, okay? Now, very important, if ATC is not in contact and I also cannot be on this air route because there are other aircrafts within this stretch of highway, right? Within this portion, there are other aircrafts also. So I don't want to pose a risk to them. but ATC is not in contact. So, what do I do? So my intention is to get out. My first priority is to get out of this ATS route. Okay, it's to come out of this ATS route first. Minimize the risk. Fine. So how do I do that? I turn 90 degrees. Okay. You can turn left or you can turn right. You turn left or right by 90 degrees. Okay. And you fly for 15 nautical miles. Why 15? Because you cover 10 here. Okay. And you fly 5 nautical miles further out from the boundary of the air route. Okay. And then you intend to fly on this deviated track. Okay. At a flight level plus minus 500 feet of existing flight level. Okay. In that case, firstly, you're outside the ATS route. Second, you're also avoiding to be at the height of any other aircraft. So you've minimized the risk as much as it is in your control. So let's see, how do we go about that? Okay. So when ATC is not in contact, okay, who do you think you're going to call? You have to make somebody aware of your intentions. And we've spoken about this in the weather deviation call also, that when any ATC is not available for you, you're going to try contacting all the other aircrafts, right? So it's going to sound like a all station call. You're going to call all the stations around you. So let's take the same example again. Okay, again, we were flying from Delhi to Nagpur. We are 20 nautical miles inbound Bravo Papa Lima. In that case, now let's say ATC is not in contact, but I still have to give this call. So what changes? Okay, keep the skeleton format in your mind while we are writing this call. Okay, so it starts with something along the lines of all station, correct? Who is calling? Victor Tango Foxtrot Lima Alpha on 121.5, right? This is the interpilot frequency. Then what's your position? Your position is 20 DME inbound Bravo Papa Lima, right? At 2210 hours, flight level 310, Whiskey 20 South. What's the problem you're facing? Enable RVSM due equipment, correct? What is our intention or plan? Okay, our intention or plan is to turn right or left by 90 degrees for 15 nautical miles and fly what? Plus minus 500 feet on deviated track. Okay? All external lights are on. TCAS is on. Right? Keep a lookout. Okay. So now these are phrases, okay? I want you to remember them as it is. Okay. So what will the total call sound like? All stations. This is Victor Tango Foxtrot Lima Alpha on 121.5. What's my position? 20 DME inbound Bravo Papa Lima 2210 hours, flight level 310 on Whiskey 20 South. Enable RVSM due equipment. Turning left by 90 degrees for 15 nautical miles and they'll fly a plus minus 500 feet, which in my case, if I were to write it as an answer, okay, I was maintaining 310, I will fly flight level 315. Okay, So we'll fly flight level 315 on deviated track. All external lights are turned on, TCAS is on, keep a lookout. Very straightforward. Always remember you're just talking to the other aircrafts, right? You want to give them all the information that you think is necessary. We learn the formats only to help us remember what all has to be covered. Alright, so you're going to call the other aircrafts, you're going to introduce yourself, and then you're going to tell them everything as if you were talking to an ATC. What's your position? What's your problem you're facing? And what is your final plan? The plan is to turn right, get out of the ATS airspace, right? And climb or descend by 500 feet so that you maintain vertical separation and also you're out of the ATS route. Okay, and you're turning on all the lights to be more visible and your TCAS is also on. So you're telling other aircrafts also to keep a lookout on their TCAS screens. Okay, so again, very simple, you can impose this onto the basic skeleton. So we've spoken about RVSM failure when ATC is in contact. We've also spoken about when no ATC is in contact. What do we do? All station call, and what else do we do? Turn left or right by 15 nautical miles and we fly plus minus 500 feet. Correct? That's what we do. Now, let's say there is no contact with ATC, okay, but you're also experiencing turbulence now. In this case, what can you do? Okay, now, very important for you to remember that turbulence, okay, the way out of turbulence is to change your level. Always remember this. And in terms of weather deviation, in order to avoid it, you could deviate or reroute. But in turbulence, you will have to descend. Okay, so now, no ATC, you know it has to go to all the other aircrafts. It's a all station call. But like we were, turning left or turning right, okay, when we had an equipment failure in turbulence, we're going to tell the other traffic that, hey, we are going to descend down, okay, to 270 or 280 depending upon westbound or eastbound. And that is what we're going to do. Okay, we're going to carry out a descent on our own. Fine. All right. So if in the same situation I was facing turbulence, what would the call sound like? Okay, the call would sound something like, all station, Victor Tango, Foxtrot Lima Alpha on 121.5. Position 20 DME, inbound Bravo Papa Lima, 2210 hours, flight level 310, Whiskey 20 south. Right? What's our problem? Enable RVSM due turbulence. What is our plan? Our plan is to descend to flight level 2, in our case 270 because we are eastbound traffic. Descend to flight level 270 and maintain. Again, all lights on, TCAS on. Keep a lookout. Okay, again, very straightforward, very easy, right? Always remember, no ATC contact, equipment failure, you turn left, you turn right of your deviated track, you fly a deviated track. But in case you're facing turbulence, while ATC is not in contact, you're going to ask for a descent. There are always, smaller situations where, let's say your ATC is busy. ATC is busy. Now, what this means is that ATC definitely is in touch with you. He's just not able to respond to you. In that case, you start your call with a pan. Okay? When it's extremely urgent for you, you want to get your message through, and ATC is in touch, but he's not responding or he's busy. In that case, you start your call with pan. One other thing which I want you guys to remember is, if the situation demands okay, to fly in RVSM airspace, but you are not RVSM approved. Okay, you can definitely fly. Okay, remember, you can fly in RVSM airspace with your RVSM equipment failed, but in that case you individually will be following conventional vertical separation minimas. You will maintain 2000 feet from the reciprocal traffic, you will maintain 4000 feet from the same track traffic. So you can fly with your equipments failed in RVSM airspace, but on CVSM flight levels. In that case, whenever you're requesting towards the end, you will add a phrase which says non RVSM aircraft, or you could also say negative RVSM. Now, important is that anytime you mention this, okay, when the ATC talks to you, every time you're responding, you have to mention that you're a negative RVSM aircraft with your call sign. What do I mean when I say this? I'm talking about this. See, let's say an aircraft requests a non-RVSM level in RVSM levels, basically. Okay. Nagpur area control, Victor Tango Alpha Bravo Charlie on 123.9er. Overhead Villop passing flight level 250 for flight level 350. So we've already been cleared, but we have an equipment failure. For some reason, we have to climb up. We have to enter that RVSM airspace. So what will the call sound like? Enable RVSM due equipment. Request flight level 350 under non-RVSM category. Understood? And let's say after the ATC clears us, ATC approves non-RVSM and RVSM levels. After that, we have to say negative RVSM. Okay? So Delhi area control, Victor Tango Alpha Bravo Charlie on 124.55. Overhead Akela at 0220 hours, Whiskey 13 South, passing flight level 240 for flight level 360, which is in RVSM airspace, right? 360 is RVSM airspace. Enable RVSM due turbulence, request climb to 360 under non-RVSM category. So this is just to make you familiar as to what negative RVSM is and what non-RVSM is and how do you use it. It's highly unlikely that you'll come across that situation in exam, but this is good to know. So yeah, that sums up your RVSM calls. It sums up what do you do when ATC is in contact and your RVSM fails, like equipment fails. When they are not in contact, what do you do? Okay, when they are not in contact and you're facing turbulence now, you're not facing equipment failure for RVSM, then what do you do? And once you're back in touch, you just inform them the same thing, okay, that I had deviated on my own or had descended on my own due to an equipment failure, due to turbulence, and will resume normal navigation if my equipments were to improve. Okay, so I think we've summed everything up. We've finished everything that there is in RVSM and CVSM calls. Make sure to watch the video. Make sure to go about a few questions. Make yourself familiar with what the procedures are. And yeah, I'll see you in the next video. Thanks. If you're looking for a place to clear your DGC exams, consider joining Wingman Aviation. We are an affordable ground school based out of Pune and provide one-on-one sessions, regular testing, and personalized lessons to make sure that you conceptually understand and ace your DGCA CPL exams. Also, if you're liking the content that we share here, don't forget to like, share, and subscribe for more exciting aviation content. Thanks for being a part of the Wingman community. Safe travels, happy landings, and I'll see you in the class again.